So, hi everyone. Today we are going to solve the fifth question, that is sliding subarray beauty. This is the question, and we are doing sliding window and particularly fixed size sliding window. So, let's go to the problem. Okay, so this is the problem we have. Let me explain to you what problem says. Like we have array, and let's say nums, and I'm taking the first example. So -1, -1, -3, -2, and 3. So in an array, the negative integers also possible. So the positive and negative combinations are there, and we have given k. What is k in this case? K is 3 and x equal to 2. So k is the length of the subarray. So this and plus subarray. If you see any question has a k like fixed size and the subarray is mentioned, subarray, contiguous or substring mentioned, then you can think of sliding window. So this is the way of looking the problem. Like the fixed size is given and the subarray is mentioned in a question. If you read the question carefully, then you will notice, yeah, we can apply the sliding window over here. So let's move to the question, what it says. Okay, x is given, so we will come to eventually what x is. So we have to find all the subarrays whose length is k, whose length is 3 in this case now. So let's take one by one. I already told you, if there is a fixed size, so the window is going like this. This one is the first window, then second window is come by adding this and removing this. Then the third window come here by adding this and removing this from the previous window. Okay, so we will go to one by one. So this is the first window we have. Now if you find the negative numbers, only negative numbers, you will get -1 and -3 is only the numbers which is negative in this window. This is the current window we have, this is, and the negative numbers are this. And if you sort this, sorting, like -3 comes and 1. So this is the sorted. Let me write it, sorting. So we apply sorting and you will get this number. And x is whatever the number, whatever the xth position, like in this case, the second position, x equal to 2, then second position, return the second position of the negative number. So this is the second position. So this is second. So we have to return this. So -1. We have to create an array. For every subarray, we have to return the negative integer. If there is no negative integer present, then we have to return 0. Okay, let's go to the next window and let me show you. Okay, so this is the our previous window. Now the current window is going to this. We have added this one and we removed this one. So in this window, this is the current window we have, and if you find the negative elements, negative integer elements, so you'll get -1, -3 and -2. So if you apply sorting, in the question it is not mentioned that you have to sort, but it is mentioned that smallest x smallest integer we have to find. So how we will look at it, like we can sort them and we can see like -3, -2 and -1. This is the sorting, and you just return the xth element. What is the xth element? This is -2, so put into the array. Then go to the next window. So let me erase all this thing. Okay, so now the previous window is this, and the current window is going to be this. How we will get? By adding this one and removing this one. As you can see, if you like this is our current window. You are adding this element and you are removing this element. Okay, so let me erase this. So this is the current window, and if you find like -3 negative elements, then -3 and -2 are the only two elements are present which is negative. And if you apply sorting, you'll get -3 and -2, and you have to return xth element. So xth element is this -2. So and if you find the next uh, window, then you are not able to find because the length is got shortened. Like you will not able to find the next element, and we have to find the subarray of length 3, and there is only two elements left in the current window, so this is not possible. Okay. Okay, so let's take another example and then we will move to the approach. So let me take the example number 3 so that you can understand it better. And I think now the approach is clear to everyone. Like, first of all, let me show you what we always do. We create the window, initial window. Okay, then we will move window by adding and removing elements. Okay, by doing this, after we have to do some things like every time whenever we created a window or we have a window, let's say this is the window, then we will apply sorting. Okay, and after sorting, we will just return the xth element. Before sorting, we have to segregate negatives and positives. So this will take, let's say, you have a k elements, not say, you have a k elements. So segregating positive and negative will take k, big O of k time complexity plus big O of k log k for sorting the k elements. Okay, after sorting, you just return xth element. And if you see the time complexity, this is not the way, this is not the right time to tell the time complexity, but yeah, if you understand the question well, then you can think of like it's a brute force approach. You are sorting every time and then you are returning xth element. uh, so the time complexity, if you assume like n time complexity for sliding window, then we have to multiply this thing k for the segregating positive and negatives, k log k for sorting the uh, k elements, and if you do nk plus nk log k, so this is the time complexity you will get. If you don't understand the time complexity, it's fine, just you understand. If you know, if you are coming with this approach, it's very fine, so don't worry about this. So let's do the second example. You will understand because every current element we always have one or two negative elements. So let's see, if there is no negative elements, what is the answer for that? Okay, so we are going to take the example number 3. So one second, let me erase all these things. Okay, so we have nums. Okay, so -3 1 2 1 2, then -3 0 -3 0 and 3. So this is our array, and k is 2 and x is 1. Okay, now let's create the initial window. This is the initial window because k is equal to 2. That means we have to take sub array whose length is 2. So if you uh, know what are the sub arrays we have, let's say this is the sub array, this is the window, this is the window and this is the window. So we can form 1, 2, 3, 4, 5. 5 subarrays of length 2. So let's say this is our the first window, and if you find the negative element, there is only one negative element which is minus 3, and if you sort this you'll get again minus 3. So we have to return xth element, and this is the first element we have to return. So let me put this into my answer list. So okay, now let's move to the next window, and next window is this. Okay, so 1 and 2. As you can see, there is no negative element, but in a question, it is mentioned that we have to return xth smallest negative integer. Okay, not a positive integer, so there is no negative integer, so you can just return 0. Okay, let's move to the next one, next window, and next window is this, and you'll find minus 3 as a there is only one element. So if you sort this you'll get minus 3 and return x element, first element, so you'll get minus 3, and so on. I'm not going to dry run again. So if there is no negative elements you just return the 0. Now I'm going to tell you one very important concept. So in a question it is mentioned that nums of I, the elements in the array, can be less than or equal to 50, or it is greater than or equal to minus 50. So this thing is very important. This thing can reduce your sorting, like it will taking like log of k, this will reduce to 50, or you can say 100, uh, which is very close to big O of 1 time complexity. If you can think of this solution, then you are good to go. And if you aren't, then stick with me. We are going to learn a new concept which is going to use like in a competitive programming. It's just a wow. So let's go. And so let's take an num uh, example. Let's take first one example. So it will be nums 1 minus 1, 1 minus 1, minus 3, minus 2, and minus sorry 3 only, and k equal to 3 and x equal to 2. Okay, and now first of all what we have to do is create a window. So this is our window, first initial window. Okay, so why we are not just count the frequency of every element, like what is the frequency of 1, what is the frequency of minus 1. You can use map, but map is not the solution. I'm going to tell you one more thing, like how do you represent like this. So if you have an vector, okay, so the index is starting from the 0, 0, 1, 2, 3, and 4 up to 50. But you can say like there is a negative element, how do you store them? So there is one trick. Let me erase this. Not a trick, but the very important concept, like minus 50, minus 49, minus 48, 0, then 48, 49, and 50. So this is the way we can represent in the vector is only this range 0 to 50. But what if you can add 50 to it every element? Let's say add 50, 50, and 50, and 50. So you will get this will become 0, this 1, okay, and this is 2, and this is 50, and this is 2 or minus 2, and this is uh, not minus 2, there is something which is very greater than 8, 98, 99, and this is 100. So you'll get a range like 0 represents minus 50, then 1 represents minus 49 and 2 represents minus 48, 50 represents 0 and 49 represents plus sorry, plus not plus 48, and for 99 represents 49 and 100 represents 50. So you can create an array like this. Okay, this is the frequency map we have: 0, 1, 2, 3, 4 and up to 99 or 100. Now you can represent index as a value. Like if you get a minus 1, so you will add like minus 1 plus 50. What is the value it will give? It will give 49. So in there between there is 49, so we will increase the count of this 49. So 49 represents minus 1, and whenever you want the value, then you will just do 49. uh, 49 is representing minus 1, so if you minus the 50, because since you have added the 50, and if you get the original number, then you have to just subtract it, you will get a 1 minus 1, sorry. That's it. This is the uh, very new concept to you if you haven't learned this before. And it's very easy because the range is very small, minus 50 to 50, so you just add the 50 to make, and if you represents the 3, this is the okay, this is the 3 minus 3. So if you do minus 3 plus 50, what you will get? 47, I think. Yeah, 47. So somewhere in 47 you'll just increase the count. And if you want like this 47, what 47 represents, then 47 plus 50, not you have to subtract, sorry, because you have added it here, and to get original number you have to subtract, you will get minus 3. Okay, if you want what 4 represents, then you have to subtract minus 50, so you will get minus 46. So minus 46, 4 represents minus 46. So this is the way to represents the negative numbers in an index. So now you are totally sorted. Like now let me show you. Let me write the array. What the array is: 1 minus 1, 1 minus 1, minus 3 minus 2 and 3. So this is an array, or k equal to 3 and x equal to 2. So this is, so the current window, what is your current window? X. This is the current window, and you will go to let me where is eraser? Okay, so this is the current window. You will just create it. Now one has a count 1 plus 50. It will be, this is 1 plus 50 equal to 51. Somewhere is 51. This is 51, let's say, and you'll just increment it the count. Initially all the elements has a count 0, so you'll just increment it with 1. Now minus 1 plus 50, you'll get minus 4, not minus 49. So just increment the count, and then minus 3 plus 50, you'll get what you'll get, plus 47, and you'll just increment the count. So this is 1, and now you have to find the negative number. So what is the range of negative number? So 0 to I think 50. So 0 to 50 you have a negative numbers. So uh, because minus 50 to 0 you have negative number, if you added plus 50 to every number, so you will get 0 to 50, you have a negative, all the negative numbers you have. So you will iterate through 0 to 50, and every time you'll see maintain a counter variable, and just counting the variable, and the xth, whenever you encounter the xth element, you'll just return. and you haven't find any x element, then you have to return 0. I hope this is understood. uh, okay, let me show you once more time. So this is critical, but uh, if you try to understand, it's very simple. So it will starting from 0, 1, 2, and there is some numbers like 47, 49 and 51. So 47, this is 49, or this is 51, and this is 100, let's say, and this is 50 over there. This is 50. Okay, so initially all has a 0, and if you have like initial window, then 51 has 1, then 49 has a 1, and 47 has a 1. Okay, now you'll go to 0 to 50 in this range, and the x is equal to 2. So you start from here like 0, because 0 represents minus 50. So you want negative number, and as you can see, there is no negative number. 0 minus 50, 0 represents minus 50, and minus 50 has a frequency 0. That means there is no element present with value 50. So you move to the next one, then you move to the next and next, and whenever you come to 47, 47 represents what? 47 represents, it's minus 3. So there is one element present as a minus 3, and as you can see, we are sorted. If you are go from 0 to minus 50 to 0, then you are going to sorted manner, like minus 50 comes first, then increasing way. So you don't worry about the sorting things. So you'll get a minus 3 first, and there is one element present in the window, and you just increment the count plus plus, and count will become 1. And then you will check if my count become equal to x or greater than x, that means this is the element we have to print. This is the element we have to put into inside our uh, answer. So if this is not, then move to the next, and again you will encounter a value which is representing the minus 1. So minus 1 is the one element which is present inside current window. So you will just add increment the count, and count will become 2, and as you can see, x and c and t counter variable equal to 2, then you have to return this value. So minus 1 is the original value we have to return. I already told you how to get the original value. So let's move to the coding part so that you can understand better. Okay, so first of all, let's create a variable called size. We will store the size of the array, so it will be nums dot size. Now, so we will create a frequency map of size 101. Initially it has 0. Let me explain to you. Minus 50 to 0 to 50. Okay, now if you add plus 50, you'll get 0, and this become 50, and this is 100. Okay, so why we will take 101? Because we also want the 100 in as an index, so we have to take 101. Okay, now uh, create a window. Create window. So how we are going to create? For int I equal to 0, I is less than k, I plus plus, and let me take a value equal to nums of I. Okay, now how we will store in frequency? So we always add plus 50 to it. So value plus 50 of index, just to increment the count. After doing this, the window is created. Now we will check. We have to check for a negative numbers. Check for negative numbers. Okay, how do we are going to check? Int I equal to 0, I is less than 50, so we will go to up to 50, because where you get minus a negative element, so 50, then minus 49, and then so on up to 0. So we don't have to include 0. So if you add 50, so you'll get 0, then 1, and so on to 50, up to 50. So we don't have to include the 0. So 50 I plus plus. Okay, now we have to maintain our counter variable cnt equal to 0 every time. Now, if my CNT plus frequency of I, that means if I am at index 0, that represents minus 50. If my frequency of minus 50 plus counter variable is greater than or equal to x, then we have to return, not return, we have to create a answer variable. It will be vector of int answer. So we have to push into that. So answer dot push back x, not x, I, the original value, so I minus 50. So if you do 0 minus 50, you'll get minus 50, the original number. And after that, cnt plus or equal to frequency of I. And one more thing, whenever you encounter cnt which is greater than x, then that means we already found the answer, so we have to break over here. And after breaking, what if there is no negative element present? So we have to check. So how we are going to check? We will create another variable flag equal to true, and whenever I encounter a negative element which is our answer, so we will make it flag equal to false, and after that we will check if my flag equal to true, then I'm just answer dot push back 0, because there is no negative elements. Or if there is a negative element, then the negative elements can be shorter, like let me show you. Let's say I have uh, two negative elements, and 4, 5 and 6. So there are only two negative elements, but I want x equal to 3, 3 third smallest negative integer. So you'll find there is no negative elements now, because there is only two elements, so which is negative. So in this case also we have to return true, sorry, 0. Now we will move window by adding and removing elements. So we will start from int I equal to k, I is less than n, I plus plus. Okay, how do we add? So let's say int val equal to nums of I. So frequency of val plus 50, remember, uh, then plus plus, and we have to remove the element as well. So it will be nums of I minus k plus 50, and decrement that down, and we will just copy it. Like, let's copy this thing. Let's not copy, let's write it quickly. So cnt equal to initially count will be 0, and flag uh, will be true initially. Now for int j equal to 0, we will start from 0 and go up to 50, and j plus plus. If cnt plus frequency of j is greater than or equal to x, then we have to put the original value into our answer, so it will be j minus 50, and flag become false, and here we are going to break. And after if condition, we have to add this thing, frequency of I into count, and last I will check if my flag equal to equal to true, then I will push answer.push back a 0. After this happens, then I'm going to return answer. So this is the code we have. Let me run this. Okay, so we are getting some error. What it says. So 0, 0 two times coming. So we have do some mistakes. Hmm. Okay, int value plus plus. Okay, count equal to 0. 50 I plus plus. Correct. Okay, everything is correct. So this is not I, this is J. Okay, this is accepted. If I'll run submit this, let's see what happens. I haven't submit. Okay. Okay, this is accepted. As you can see, all the test is passed. And if you try to find the time complexity, you'll get big O of n, because this will take, the inner loop will take big O of 50, and big O of 50 is approximately big O of 1, so it's constant, and the time complexity would be big O of n into 50, so it's approximately big O of n. So this is the time complexity, and we have marked as a done. So there is only one question remain in a sliding window, fixed size sliding window. So we'll do it next video. So thank you for watching.